Good evening. It's lovely to be back at Bristol JS. For those of you I haven't met before, my name is Léonie Watson. I've been working on the web since the mid-90s, most of that time in accessibility. Most recently, I'm kicking off a startup in the accessibility space called Tetralogical. And we're trying to move accessibility away from the professional obsession with audits being the answer to everything, and instead focusing on more useful and earlier parts of accessibility, things like getting pattern libraries, component libraries, and design systems accessible before they start being used to deploy sites. Taking accessibility into new areas with virtual reality, voice assistant applications, prototyping and researching solutions around those. So it's an exciting and crazy time, and great to be back here in Bristol, having a chance to talk about some of the accessibility things that I think are amongst the most interesting. And so on that note, I'd like to talk a bit about accessibility mechanics, the past, the present, and the future, and why as developers we need to call on all three of those time eras in order to do the best that we can with accessibility at the code level. Browsers. These will be very familiar to all of us. At the moment, for the time being at least, we still have 4 browser engines out there to work with. Unfortunately, we're about to lose Edge HTML as Edge shifts over to the Chromium engine. But for the moment, these are the 4 that we most commonly deal with in our day-to-day work. What might be less familiar to you are pieces of software called screen readers. To some extent, the speech synthesis that Ian was demonstrating in his talk just before is part of screen reading technology. It's taking content on screen and translating it into synthetic speech. So someone who's like me, who can't see what's on the screen, can actually still interact with it and understand what's going on. And there are screen readers now on pretty much every platform, whether it's Windows, Mac OS, iOS, Android, and most Linux distros that are in common use today. So there is a screen reader available on all of those platforms, which is really good news. It hasn't always been that way. So if we look to the past, back as far as the 1990s, there were pretty much only Windows screen readers at this point. There did used to be one for the Apple operating systems, but they quit developing it, or at least the third-party supplier quit developing it in the mid-90s. So Windows really did rule the screen reading world for most of the 1990s and into the early 2000s. And what used to happen was when an HTML document was loaded into the browser would take that HTML, it would parse it, it would create the visual rendering, it would provide the interaction where necessary for things like form fields and other interactive elements. And then the screen reader would come along and it would do more or less exactly the same thing, completely independently of each other. On the one hand, this was quite useful from the screen reader user's point of view because they ended up with a virtual copy of the page that they could interact with. That made it possible to navigate in different ways much more easily than would otherwise have been possible. On the downside, having 2 UAs go away and do completely separate things with the same document quite often led to very distinct renderings of the page, not always distinctions that were useful to anybody in question. So we can see a screen reader in action doing this with this sort of model and just reading some text from a web page.
Heading level 1 using the ARIA current attribute posted in link code things on January 14th, 2017. It is common on the web for the current thing in a collection to be highlighted visually, but providing an alternative for screen reader users has often involved something of a hack. The link ARIA current attribute is intended to solve this problem.
So because of the virtual model, the screen reader is able to identify the different types of content there and to read the text. But it was a pretty basic system. There was a lot of guesswork involved, and the screen reader had to do as much heavy lifting as the browser did. So 2 user agents doing equal amounts of really hard work. By the time we hit sort of middle of the 2000s, Apple had introduced a screen reader of its own, VoiceOver, and the way screen readers on both platforms worked had changed pretty fundamentally. They started using things called platform accessibility APIs. These have been around since the mid-90s, but took their time being introduced into browsers. And what these APIs enabled screen readers to do was query information from the browser about content that was on screen. So instead of having to do their own guesswork and their own rendering of the HTML, they could ask the browser for its interpretation and use that information instead. Like screen readers and operating systems, we've got platform accessibility APIs on pretty much every operating system. Windows still has 3 at the moment. There's one available on Mac OS, iOS, TalkBack on Android as well, and on Linux. And these, as the name suggests, operate at the platform level. So a screen reader can actually ask the operating system via these APIs, what is that object on screen, whether it's a window, a menu, a button within an application, or now part of the browser web content. So it takes a lot of the guesswork and a lot of the heavy lifting away from the screen reader and puts it back into the hands of the operating system, or in the case we're interested in, the browser. So it means that when we use HTML elements, for example, the main element, the browser makes a lot of information available to the screen reader. It says this element has a particular role, in this case that it's the main content area of the page. The screen reader, when it encounters this, will say to the browser, tell me everything you know about this element. And then it'll grab that information and convey it to the user. And it'll say something along these lines.
Main region.
Quite simply that. It'll just tell the user that they're dealing with the part of the page that has the main content in it. The nav element has something pretty similar. It has a role of navigation according to the browser's information on the element. And the screen reader takes that and conveys this to the user too.
Navigation region.
The nice thing about these elements is that they also act as navigational landmarks. So screen reader users can use a shortcut that's available to move between all of these different types of element in HTML. So all the sectioning elements like header and footer when they're scoped to the body element, the main element, aside and nav can be used as navigational hooks for quickly and easily getting around the big kind of high-level chunks of a web page. Doesn't stop there. All of these elements, or most HTML elements, have this role information made available about them. So the list elements have a role of list, and we can...
List of 3 items. 1, do this. 2, do that. 3, do something else. List end.
So the screen reader picks up the fact that it's a list. In this case, the browser also counts up the list items inside the parent element and lets the screen reader user know how many list items there are inside a list. So one of these good reasons for using a list when you've got a collection of items like this is because it sets up the expectation of how much information is available on the screen to deal with. Something that most people can take in at a glance is conveyed to someone who can't see because the browser's counting up those list items inside the list, and you know how many list items there are going to be as you progress through the content. Headings are another one. All the H elements 1 through 6 have a role of heading. And again, that information is communicated along with the property, in this case of the element, its level.
Heading level 1.
And again, that just very simply gets communicated by the screen reader. It also works with the state of different elements. So if we have a checkbox that's checkable, then that information also gets exposed by the browser in the accessibility layer, and the screen reader makes use of it.
I live in the UK checkbox not checked. Checked.
So lots of information gets made available by the browser that the screen reader can query through the accessibility APIs and do something useful with for users. We'll look on one last example here, which will take us through the rest of the talk in some respects, and that's our accessibility talk favorite, the button element. In this case, we're going to take one that might be part of a video interface perhaps, or an audio player interface, just a simple play button. Using a button element that unsurprisingly has an element of, a role of button.
Play button.
And so the screen reader picks up a lot of information from that. It picks up the role of button, conveys that to the user. In this case, the button also has an accessible name, which it just takes from the contents of the button element. So if there were multiple buttons on the page, we assume they'd all have a different accessible name if they had a different purpose. And again, all that gets picked up by the screen reader from the browser. So that was the past. That's all the accessibility information that's baked into HTML, and it's been like that pretty much since the beginning. So we have a lot that we get for free if we can use HTML in the way that it was originally intended to. In the present, however, we don't always have that luxury. We often now create things that don't exist in HTML. Tab panels are probably the easiest example of that. We also use frameworks, and for a bunch of other reasons, use div and span elements as the primitive building blocks to create custom widgets, custom components. often to recreate existing HTML elements for reasons best known to somebody else. But that is the reality of it. It's what we find ourselves dealing with today. So the problem with div and span elements is that unlike almost every other HTML element, they don't have a particularly well communicated role. In terms of accessibility, they're pretty inert. You can't focus on them, you can't interact with them. They have no accessibility information that gets communicated about them. They just pretty much sit there and do absolutely nothing. So if we see an example like this, where we've got some divs and spans, probably styled and scripted to behave and look like a toolbar, all the screen reader is aware of is just the text inside of some pretty inert elements.
Bold. Italic.
And so it doesn't matter what it looks like, doesn't matter what it's scripted to behave like from the screen reader user's point of view, from the accessibility information in the browser point of view, that's just two pieces of plain text and absolutely nothing more to it. The good news is that we can polyfill some of this accessibility information when we need to, using, as Ian mentioned, the ARIA specification. 1.2 is the current version of it. They're working on, 1.1 is the current version. They're working on 1.2 at the moment. There's also another spec out there which instructs how to use ARIA, or which ARIA roles can be used with specific HTML elements. So those are two specs worth paying some attention to as you start thinking about adding accessibility information. There's the role attribute in the ARIA spec. So where we just saw that lots of HTML elements have native roles of their own, we can add a role in or even change a role if we need to using the role attribute. There's about 70 different values at the moment in the 1.1 specification. Pretty much every HTML element, UI component you can think of, there's a role for. So radio buttons, checkboxes, tables, rows, cells, even complex components like progress bars, menu bars, toolbars, trees, grids, all sorts of things. So roles that we can add in when they're not available in HTML, there's a good amount of them to choose from in the ARIA spec. There are also 45 odd ARIA prefixed attributes, and these are the things that let us add in missing information about the state or other characteristics of whatever it is we're creating. So ARIA invalid if something's in an invalid state, ARIA required if it's needed, for example if you're building forms, aria-pressed to show that something is on or off, aria expanded to show it's expanded or collapsed, like you might find in a disclosure widget. Lots of these that can be used to convey different sorts of information about the state or other properties of an element. So if we take an example, we'll go back to our button element, our play button, but this time recreate it using a span. So as I said, a span is pretty much dead in the water when you first start to use it. So we've got a span, it might look like a button, but we're going to have to do a lot of legwork to get it to work properly. So we can start by adding the role attribute, this time with a value of button, because that's what we're trying to communicate. At this point, it's still a span in the DOM. It's only in a structure known as the accessibility tree in the browser, which is a sister structure to the DOM, that this is now, to all intents and purposes, a button. So just worth remembering there is that separation of concerns there. But in the accessibility sense, at least from the screen reader's point of view, our span is now, to all intents and purposes, reported as being a button. Still doesn't really behave like one though, or function like one. We've got to make it focusable. You can't focus on a span by default, so we use tabindex with a value of 0 to make it focusable. So if you're a keyboard user, sighted, or whether you use a screen reader, you can now tab key onto this button, which is a useful first step if you need to interact with it. We then need to put in the interaction. The mouse interaction is often the obvious step, but we also need to make it function for keyboard users too. So we listen out for the key codes 13 and 32 because buttons are expected to respond to either the enter key or the space key. And then we just attach that into the expected functionality. And what happens when we do all this is we get something that looks remarkably like our original button.
Play button.
Which is probably why it's worth saying there's one piece of missing information from that, and that is that as that button is toggled, it changes visibly, but that information isn't at the moment communicated by the browser to the screen reader. And we can add that bit in by using the aria-pressed attribute. When set to true, it will indicate that the button is pressed. When set to false, it'll be the reverse state. And this is one of the really good examples where this doesn't exist in HTML. There is no equivalent natively in HTML. You have to polyfill this using ARIA. We need to chuck in some functionality, because why else have a button? In this case, we're just toggling the state of the aria-pressed attribute in response to the button being hit. It's not doing anything much more interesting than that in our particular example. You can also do something neat, and that's hook in the functionality using a CSS attribute selector. Basically, this is just a neat way of changing the button's visual appearance to show its on or off state based on the state of the aria-pressed attribute. It's really easy when you're using ARIA to sort of forget about it, because it's only consumed by screen readers. From a visual point of view, there's no obvious way when you're testing your page to know whether it's working or not. You've got to test it with a screen reader. By hooking the visual state into the accessibility state of the button, you've got a pretty good early warning sign. So if your visuals aren't working, it's a clue to go and have a look and dig around and see if maybe the accessibility strand of the piece isn't working as well. It also just simplifies code. You need less classes or IDs or anything to hook the styles into, so it's just a little bit of a neat trick there that's quite useful in a couple of different ways. And so what we end up with now is a slightly different button to the first one that we looked at.
Play toggle button not pressed. Press. Not pressed.
So it's now announced as a toggle button rather than just a straightforward button. The screen reader recognizes it's something that can be toggled on or off. And as it's interacted with, its pressed or not pressed state is picked up and communicated by the screen reader. So we've got something that is now, for screen reader users, a much more comparable experience as it is for sighted users of any description. And we've done that partly by doing a fairly atrocious thing, which is starting with a span instead of a perfectly good button element. But we've also added in the pressed state in a way that we couldn't, no matter how much native HTML we wanted to use. And I am duty-bound to say that, of course, all of that could be done much more easily by using the button element in the first place and just throwing in the aria-pressed attribute, because, you know. So something else we're seeing in the present right now is more and more use of custom elements. This is now hitting a lot of production-level code. British Gas, for example, just released a new version of their homepage, and sizable chunks of that now consist of components that are either custom elements or web components. And so we can use ARIA to help us polyfill this, and also just to create simpler versions of things that don't exist natively in HTML at the moment. So we can set up a pretty simple custom element constructor, and we're going to use it to recreate our toggle button, but in a way that can just be used much more simply at the point you want to add it into the page. So we're going to extend the button element because we want to take a lot of the goodness of the original button element. We're going to hook it in. So custom elements use something called a shadow root. That's the point where all the code and the other bits and pieces we put into our custom element hook into what is entered into the page at the code level. A good example of this is when you use the audio or video element. When you use either of those things, you never see the code that puts in all the buttons and the controls, assuming you've got the controls attribute present. The browser just renders them automatically and kind of takes care of business. And to a certain extent, that's pretty similar to how it works in custom elements and web components. We can put a lot of code and a lot of features and functionality and bits and pieces in, and that automatically gets generated. If you go and inspect the code after you've used one of these custom elements, you won't ever see all those bits and pieces that are going on under the hood. So we start setting that up in the custom element. We're just going to decant the functionality from the custom button example earlier into this, just for efficiency's sake more than anything. So we're just adding in the ability for the button to change the state of the aria-pressed attribute. We're using inner in HTML to enable someone, when they use this toggle button element, to add in text exactly as you would with a button element, just to add in the accessible name. And so what we end up with something in the HTML is as simple as this. It's just toggle-button. We put a label in the middle, play again exactly as we did with the button element. So it's very, very simple to use. We don't need to worry now every time we want a toggle button element about all the JavaScript, all the other bits and pieces. The reason for the hyphen in the name is just a rule of creating a custom element. It's necessary to distinguish them from original native HTML elements. So when you create one, it's got to have a hyphen or a dash in the middle of the name just to keep that separation of concerns. And so what we get now for just putting that toggle button element into our HTML is effectively a creation of the one we've been seeing pretty much all the way through this talk.
Play toggle button not pressed. Pressed. Not pressed.
And of course, the nice thing about that is because it's a custom element, it's reusable. So anytime anybody wants a toggle element anywhere on the site, they've just got to use that HTML element, and providing they call in the custom element script behind it, we can pretty much call that done. Except for one little thing. If you do look at the render code as you look at it in the DOM, what you'll find is that the aria-pressed attribute has leaked out of the custom element code. All the stuff that's supposed to be hidden away and not available for inspection has actually made its way into the DOM for this element. It's perhaps not a big deal. Some people are very stringent about keeping their code clean and tidy and keeping concerns separated. And so it perhaps isn't ideal in terms of keeping custom element code hidden away in the way that's intended when you use them. And so that brings us to our future. We haven't solved that particular problem, but there is at least one thing underway that's aiming to do that. And it's called the Accessibility Object Model, the AOM. It's a JavaScript API, or at least it will be when it comes to fruition. It's being developed by the Web Incubator community group from the W3C. It's available on GitHub. Please do go take a look, check it out, wade in, and add your comments, because there's a lot to think about when it comes to this. Phase 1A of this aims to introduce ARIA element and attribute reflection. So at the moment, when we're using custom elements, or whether we're just creating custom widgets and components of any kind, we have to use JavaScript along the lines of element.setAttribute, and then give it the name of the role and the value that we want to give the attribute. Phase 1 of the AOM will just switch that around, so the syntax becomes a lot more familiar. We can just use element.role equals and then the value of the role. So phase 1 of this, I think, has a lot of merit. It'll make coding just a lot simpler, a lot more consistent with the ways that we tend to do things currently. So far, so good. Phase 1B, I think, is another good thing. It means that particularly when we create custom elements or web components, we'll be able to set certain immutable accessibility characteristics at the time the custom element is created. And this is exactly what the browser does now. When it creates the main element, for example, it sets the role of main, and that doesn't change to all intents and purposes. That's a defined characteristic at the time the element is rendered. So we'll be able to do things like that. We'll also be able to change accessibility characteristics in custom elements based on user interaction. So it'll make it easier to do things like change the state of the aria-pressed attribute if we need to when the time comes. So again, I think the AOM is looking to introduce some useful things. If they get as far as phase 2, what will happen is they're going to start looking at user events. So we have lots of events for all kinds of interaction, keyboard, mouse, all the rest of it. But there are a few gaps when it comes to particularly accessibility and almost exclusively mobile. So there are no easy ways to emulate increment and decrement from an accessibility point of view. And we see this all the time in components on touchscreen devices. Similarly with scrolling pages, this is applicable right across the board, but again, especially on touchscreen devices. When you use a screen reader, particularly on a touchscreen device, your gesture set changes completely. And so hooking into a flick up or a flick down to increment or decrement something, or a three-fingered scroll up or scroll down, swipe up or swipe down to scroll, we want to be able to do that. So again, there are some pretty good use cases for looking at these events. Phase 3 is where things start to get a little bit interesting, shall we say. This is where it's going to enable us as developers to start interacting with the browser's accessibility tree directly. At the moment, the browser is the only thing that has control over that tree. It renders the accessibility tree when it creates the DOM and does all the other bits and pieces. And it manages that entire sister relationship between the two structures. If phase 3 comes along for this, we're going to be able to interact with that for ourselves. And in some respects, I think that's quite useful. For example, one of the techniques we see a lot of is hidden text on a page, purely for the benefit of a screen reader user. It might add a bit of context to a linked text perhaps, or a quiet instruction to help someone do something. The problem with that is that we most commonly use CSS to hide that information, but if you happen to be someone who doesn't use the style sheet provided by the website, you're using your own style sheet, perhaps to solve a readability or a low vision problem, that text automatically becomes visible, and it may not be as useful to someone who has some sense of vision, and so it starts to get, potentially a little bit messy. If we could actually just inject that information straight into the accessibility tree, where it would pretty much only be used by screen readers in that context, that's perhaps a much neater way of doing it. The concern is that we could end up with two entirely independent things going on the page, almost a regression back to the time of the 1990s, where you've got one thing happening in the DOM and a completely other thing happening in the accessibility layer. So two almost independent renderings of the same content, and depending on how divergent they get, we could be looking right back at all the problems we solved 20 odd years ago. I'm in two minds of this. Part of me recognizes the potential for the danger in that. The other half of me thinks that if you're the sort of developer that has got yourself to the point where you've understood ARIA, browser mechanics, accessibility mechanics, and the AOM to the point you're able to use it, there's probably a fairly good chance you're not going to use it to do anything really that stupid. That's my hope, anyway, but we'll see. The last part is that developers will have access to the computed accessibility tree. So you'll be able to walk the tree pretty much the same way that we can walk the DOM. In the same way that we get computed styles for things, we'll be able to get the computed accessibility information for things. And this completes the plans for the AOM at the moment. There was an earlier version of the AOM that used something called Accessible Node. That did have some implementation in a couple of browsers behind the flag, but they've rewritten it since then. And this current version now with the element and attribute reflection doesn't yet have any implementation. So it's still very, very early phases. And one of the good things about that, as I mentioned just now, is that it gives us all a chance as the developer community who will end up using this to feed into that process. And one of the big questions that we really need to answer is that of privacy. For the first time with this, we'll have an absolutely concrete way of fingerprinting someone who has a visual or reading disability. ARIA is only really consumed by screen readers. Screen readers are majoritively only used by blind or very low vision people, and sometimes by people with reading disabilities like dyslexia or concentration difficulties, such as people who are on the autistic spectrum. But for the first time, it will be absolutely unequivocally possible for a developer or creator of some JavaScript to know that the person consuming the website is a person with a disability. And that crosses a pretty fundamental line in terms of personal information and privacy. Any other concept, like whether someone uses a keyboard, whether they adjust any other feature on the website, cannot be tied exclusively to having a disability. This will be very, very different. The argument, of course, goes, well, if we know someone's using a screen reader, then we can improve the user experience for that audience. The problem with that is, as I just mentioned, we don't know why someone's using a screen reader. We could play the numbers and say, sure, most people are going to be blind, but I know at least one screen reader user who is on the autistic spectrum who really struggles when things are adapted for screen reader users who are blind because he's a screen reader user who's sighted. So even if we decide to do that customization, trying to work out who or what we're customizing for is really, really difficult. And then that's fine as long as everybody's got really great intentions, but I really don't want every advertising tracker script on the planet knowing I've got a disability and assuming that they know what that means in terms of what they want to advertise at me or what information they're going to sell about me. And that, more than anything, is the kind of really, really scary bit about the AOM. So lots of fundamental engineering questions to answer, some philosophical ones to answer. And again, I really do encourage you, please go take a look at that GitHub repo. Chuck in your thoughts, because the W3C more than anything needs input from developers who pick up their specs at some point in the future and use them in their day-to-day jobs. So your input is incredibly invaluable. So just to finish, more or less where I started, which I suppose is apt for a time traveler's guide to anything. To be really good developers in this day and age, we need to understand all of this. We need to understand when and how we can get as much as we can for free from HTML. We need to understand what we can do to fill in the gaps when that isn't possible, because this is the real world and HTML isn't always possible in the best way. And we need to look to the future and to the solutions that are coming our way that in the next few years are going to be part of our toolkits. And we need to try and help shape those as much as anything. So to get accessibility right, whether it was 20 years ago, in the current age, or for the next N years, we need to pull on all these skills and all this knowledge and draw on the best of all of them to try and make things as accessible as we can be. So use the best of the past, the present and the future. And on that note, thank you very much.
So many years ago, screen readers who private users would often have very out-of-date software because the cost of upgrading is always so high. Has that changed in recent years?
Yes, it has. Certainly in reasonably well-funded Western countries. Back in the sort of time you were referring to, sort of in the 90s, early 2000s, Windows screen readers were proprietary, and their cost was in the sort of hundreds of pounds bracket. Apple sort of really started changing that game when it introduced VoiceOver, which is integrated into all its products. So it comes for free. The catch, of course, is that Apple products cost a good deal more than your Windows project. So that solved part of the problem. They started we can do this as an integrated part of our operating system. NVDA is an open source screen reader for Windows. Evolved at roughly the same sort of time, courtesy of a bunch of very talented developers in Australia. And so that started to change the game for Windows users. Windows 10, the narrator screen reader is built into Windows 10, and over the past couple of years, that's actually now become something much more akin to a fully fledged screen reader. It was there since, I think, XP, but it was about as useful as the speech synthesis API is. It could talk at you, but had none of the characteristics of a screen reader, whereas now it's actually pretty damn good. So just the availability of free and or integrated options has changed that completely. There are a lot of parts of the world, of course, where even getting the latest operating system and therefore an integrated anything is still much of a challenge. But yeah, certainly for here, it's made a hell of a difference.
Would you say that people actually do upgrade now?
Yes, they do. I forget the stats. If you or I can ping you a link afterwards. There's a WebAIM do a every couple of years-ish survey of screen reader users. One of the stats they include in there is how often things are updated, and even because lots and lots of home users are shifting to the free or integrated ones, which tend to automatically update, they're sort of taken care of. But what we're starting to see is that businesses are now the kind of the main purchasers, if you like, of the proprietary ones, and although they're not excellent at keeping things up to date, they've often got more money to throw at it than home users used to, so that gap is closing. I will add that actually JAWS, which is still the market leader screen reader, it's one of the proprietary ones. In the States, they've just launched, I think it's a $90 a year home users sort of, Office 365 kind of based idea subscription. So if they introduce that sort of around the world, then that will fundamentally change that as well, because $90 a year as opposed to several $100s to purchase outright, in itself will help close that gap a bit more. So it's not perfect, but it's closing.
So I heard that JAWS, initially you could get it off your council if you applied and you were eligible and they had the funding that year. But effectively it actually implemented the standards very badly. But because of its market share, it was claimed as the best offering.
Actually, from a technical point of view, it is, I think. It's the one I use out of choice. Obviously, I'm fortunate enough that I can afford to use it, but if I haven't done any thorough side-by-side comparison, but I switch pretty routinely between JAWS Narrator and NVD. Windows is my choice.
NVDA had a problem where it was only two developers, a bit flat for a few years, but effectively the community is so strong, it's actually great now.
Yeah, and actually now if you are advised by the Access to Work team here in the UK, you'll almost always get told to use NVDA on Windows or VoiceOver on a Mac. Partly because they haven't got the funding to pay for JAWS either. So yeah, and then actually, the NVDA team did have a lot to prove in that respect. Organisations get really twitchy, around whether open source is a sustainable model. And actually now they've proved they've got the community, they've got funding from the likes of Mozilla, Microsoft, so on. So yeah, they've done a hell of a job.
You mentioned about the work that you're doing now around VR.
Mm-hmm.
Could you kind of talk about what approach you're taking to that work, and is it specifically web VR?
Yes, so web VRs are a really big focus, and there are lots of things going on. One of the things I'm working on at the moment is putting together an inclusive XR, actually, which is the name that W3C has come up for, a combination of virtual and augmented reality. But a workshop that will bring together people from all of those fields, accessibility, inclusive design, to start looking at some of the problems, some of the solutions. There's already work going on looking at captions, for example, in 360 and or VR environments. How do we handle that when the speech could be coming from anywhere around you? How do you indicate that to someone who's deaf and can't actually hear the orientation? So what visual signals can we put in place to say, the voice is coming from over there as opposed to, somewhere within your viewport at that time? Looking at things like how we handle audio description in real time. And this is what was so interesting about Ian's idea with the speech synthesis API. I'm pretty convinced that writing text descriptions in the kind of old school way that we do for things on the web at the moment is just never going to work inside a constantly evolving or updating virtual reality. So the question is, can we plug in some AI that consumes the virtual reality to get the data from it, hook it into something like the speech API to spit out some useful descriptions of the environment around you? Can we use things like vibration API to make haptic feedback possible to, A, enhance the experience, but B, for hearing impaired people, again, can we do more to notify them about events that are going on around them? So it's a really early stages area at the moment. It's a nice time to be involved in it, really, because there's a lot of exciting possibilities.
Do tools like Canvas or WebGL have any accessibility considerations built into them at all?
Nope. Nada. Zip. No, so the Canvas element, other than the Canvas element itself that's hooked into the DOM, is entirely JavaScript. And so it has no semantics, no nothing. I haven't looked at it for a while. A good friend and recently ex-colleague of mine, Steve Faulkner, did some blogging about it a couple of years ago, and the only real way to deal with Canvas accessibility at the moment is to build a kind of fallback DOM inside it, which is limited at best, and the same for WebGL. In and of itself, it has nothing to work with, unfortunately.
It's good to know, thank you.
What's your favourite website in terms of accessibility?
So I will say this with complete transparency that I worked on it for a long time, but the Gov.uk website, if you want accessibility at scale, I think still does a really good job of it. And their kind of putting user needs first has been absolutely fundamental in them achieving that. Other websites, I think, are really accessible. That's hard to say. Whole accessibility is really hard to come by. There are things that have got good features. Supermarkets actually don't tend to do too badly. They tend to do quite well. If you want a good accessible app for anyone who's a Barclays Bank customer, their banking app is extraordinarily accessible. It's really good, and they've put a lot of time and effort into it. So yeah, there are some good ideas out there. I should just keep a list of these because I'll get home tonight. Oh yeah, that one. I never can remember them when somebody asks me this, but yeah, there are some good sites out there that do it and do it even at scale. I can give you one website that's just done a terrible thing though, which is Next, the clothes store. They've just decided to publish an alternative accessible version of their website, which isn't terribly accessible, but it's a bit like kind of, I always get really angry about this, but it's a bit like kind of saying, you disabled people, just go use that other website. Really? Didn't we quit doing that in the 60s with other kind of unfair civil rights things? So yeah, if you want a really good example of how not to do it, that's my current bee in the works. So yeah.